9. So what is the standard form equation of the line shown below? So graph of line is going through -3, -1, and 3 and 2. So I have 2 points. I'm given -3 and -1, and I have 3 and 2. So take a moment to think about this question. I'm gonna grab a drink of water, and what you're gonna do is what is the standard? You're gonna look at these 4 solutions. You're gonna figure out which of these functions would go through these 2 points. So let's take a moment to think about that. So remember, if you have 2 points, what can we solve for first? We can solve for a slope, right? So let me write down the slope equation for you. So this is m equals y2 minus y1 over x2 minus x1, right? And we know that this here is x1, y1, x2, y2, right? So we can solve for our slope first. So let me take a moment to do that. And if you're in the chat, maybe wave hi again. Let me know that you're here. And yeah, how many solve for the slope here? So if I have y2 would equal, y2 would equal 2 minus y1 here is minus 1 over x2, which is 3. This -3 here is minus 3, right? So to get 2 minus 1 here is 3. 3 minus 3 is 6, which means my slope here is half, right? So let's verify our solution here. Our slope is indeed half, which is good. And now let's look at all the options here. So they got the slope correct. I did as well. That's good. So A says that this is y plus 1 equals half x. Y plus 1 equals half of x plus 3. Okay. What we could do is, if I want to isolate to y-intercept form, I have to isolate for y, right? So I would subtract 1 from both sides. And then what I can do distributive property. I can do, this would be half times x times plus half times 3, which is 3 over 2 minus 1. This was simply a half x plus half here, right? That's going to be my my first equation here. In this case, the slope equals this, right? So A1 could be possible. Okay, so this here could be possible. Let's look at B. B here's y equals, this is also half x plus 5 over 2. Again, my slope here is also half, right? So this here could be a solution as well. Let's look at C here. Is negative x plus 2y equals 1. I would have to isolate for my y, right? So I would have, I would add x to both sides, and then I would isolate for my y here. So I would get 1 plus, or I would divide everything by 2 here, right? So I get a half plus 1/2 x here, which is actually the same thing as A here, which is odd. Very odd here. Because I got the same solution here. Anyways, okay, that's kind of weird. And then let's look at D. Is it x minus 2y equals -1? Again, I'm isolating from my y, right? So I have -2y equals -1 minus x, sorry. I'm subtracting x from both sides. And then I would divide everything by -2, right? So if it's divided by -2, I would get a half. This would also be plus half x. Again, these two are also the same, right? So this is kind of odd here. So I'm just going to check here. So all 4 of these solutions are valid, right? So what I would have to do is I would have to check some of my points, and for me to do this, I would have to sub in my point into this equation to see if it satisfies that equation here. So I'm going to see what they did here. Find value of b. Okay, so they're finding the value of b for this point here. So that's good. So let me do that. So I have here, for my 2 points, I have y equals mx plus b, right? And I know y half I solve for. So I know it's half x plus b here. And what I can do is I can plug in any of these 2 points, right? So let's take the point -3, -1 here. So -3, -1. So I have -1 equals half times -3 plus b, and I'm going to isolate for my b. So negative 1 half times negative 3 is negative 3 over 2 plus b. And I have negative 1, I'm going to add 3 over 2 to both sides to get me b. So b here would equal, this is just simply half, right? So in this case, my equation here is y equals half x plus half, right? So that's going to be my my y-intercept equation here. And so b equals half, so we have this, this sort of equation here. And then what we could do is, like what I did was I actually converted all of these into y-intercept form. But you could convert this into a standard form, right? You could multiply both sides by 2 in this case. So I would get 2y equals, I would just simply left with x, and this was plus 1, and I could manipulate this and send, I could send x to the other side. So I have 2y minus x equals 1, right? So if I look at my values here, 2y minus x equals 1 would look like 2y minus x equals 1. Doesn't really look like a lot of these ones here. 2y minus x. You could rewrite this as negative x plus 2y. So maybe it's option 3 here in this case. But they said option 4 is correct, which doesn't make sense. I have half x. This math is correct here. I'm multiplying 2 by both sides here, which is good. And then I have equals negative 1. How did they convert 1 to negative 1 here? I'm so confused. If you bring x to the other side, get 2y minus x, right? Equals 1. I don't know how this became negative 1 here. Unless they multiplied both sides by negative 2. You would get negative 1. But this was 1, right? This last part is not is not correct here. So with my math, this is 2y minus 1. Or you could rewrite this as negative x plus 2y equals 1. So in this case, option 3 is correct for my equation here. But if I look at my all my solutions here, I have, if I did the distributive property, I go to half x plus half. This is also half x plus half. This is half x plus half, and this is half x plus half. So actually, I believe that all of these solutions would go through this point here, but I'm going to say that this solution here is incorrect because this here algebra, incorrect solution, because the last part was very, very confusing. I don't know how they got 1 and then this simply became negative 1 here. Like I have, if I move, so if I want this to be negative 1, I'll have to move this right side. So let me see what they did here. I'm very curious. So I have 2y equals x plus 1, right? And then I have negative y, so which means I have to move 2y to negative 1 to get x. And then I have to do, I would have to do, I'd have to move 2y back here, right? So this would be at negative 1 equals x minus 2y. Okay, so this actually works. This works. I'm sorry, I'm confused. So their math here was correct. This here's 2y. So I have negative 1 minus 2y. This here is correct. But however, 3 is also correct, right? Because if you looked at my solution here, 3 is also correct, right? I added 2. I multiplied 2 by both sides here. Because I could actually, because this equation here would equal this equation here, right? If I had something like negative x plus 2y equals 1 here, I can manipulate this to get this, right? If I moved 2 to the other side, so negative x, or sorry, if I moved 1 to this side, I get negative x plus 2y minus 1 equals 0. I'm moving x to the other side, so I have 2y minus 1 equals x, and I move 2y to the other side, it's negative 1 equals x minus 2y, right? So this here, these two values are also the same here. So again, all of these solutions here are correct. So in this case, incorrect solution because those 2 points go through all all functions, all 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 four linear equations. Because it's incorrect because not only 4 of them here, right? All options have the equation half x. It's half x plus half, right? Plus half, right? So y equals half x plus half. Therefore, both points would go through all the. Therefore, all solutions are correct. So so this is kind of a trick question because it says all solutions are correct, not just one, and we prove that using our algebra here.